So looking at this, when I first got this title, I thought, okay, throwing acronyms in already, well done. That's really going to make us impressed. And as we've got our acronyms expert here, what does NPS mean? Net Promoter Score. Can you get that in the next one?
So I think that's a great way to kick it off. Who in the room uses a Net Promoter Score? One person. Okay. Oh, two. Okay. So Net Promoter Score is just a polling tool. It is the simplest polling tool you can imagine. You get a question. It says, do you like this company? Do you dislike this company? Or are you neutral? That's it. The Net Promoter Score is out of 100, and it tells you out of 100 people on aggregate, how many of those folks will say they like your service. That's all a Net Promoter Score is. It's a really great tool to measure yourself. It doesn't tell you a lot, but it gives you trends. If you see your Net Promoter Score going up, you're doing something right. If you see it going down, maybe check. Because it's just one question, you can get very iterative data and you can measure yourself. I measure myself as a vendor. I strongly recommend everybody use it as a tool for your teams, for your employees, for your customers. It's just a tool to see where you're trending. And I think I wanted to show how we could utilize that data and that mindset and that tool to guide us, to take some engineering data, iterate on it, and focus our efforts to actually make a better service for our customers. So, driving the economics with NPS scores. I want to start off with who am I? Because it's a pretty broad topic and I want to make sure that you understand where I'm coming from. First of all, I'm Dan Gledhill. I've been in the industry, in the telco industry, in the cable industry for about 15 years. I ran sales for about 12 years for our friends over at Vestma, and I've recently joined Harmonic 364 days ago, which is a fantastic number for those who understand US non-compete laws. We are a major provider of broadband technology in the space. We currently have an Emmy for a virtualized core. I think I owe Brian a thank you for teeing that up for me, because a lot of the visions that were described have been executed on and realized, and I think that's largely what we talk about when we talk about our virtualized core. We have over 26 million customers today deployed on this system and on this solution. So we talk about sort of AI. I actually don't call what we do AI, but machine learning. And you ask, well, how did I get good data? I've had 26 million customers deployed. I've tested it, I've verified it, I've actually measured myself against real world data, and that's how I'm coming up with this guidance and recommendations for you. Also, I think somewhere up there were over 100 global deployments, so those 26 million are spread out over all sorts of technologies, ecosystems, Europe, US, Australia, Asia. It's a really broad, diverse set of customers, Latin America as well. So, I wanted to use NPS scores to talk about how we could focus our efforts. And again, I'm thinking as an operator, what do I care about? Where do I focus my efforts to ensure that I'm delivering a great broadband service to customers? Speed. Wait, hold on. Speed was 2019. Nobody cares about speed anymore. That's table stakes. Let's talk 2024. In 2024, customers of broadband services care about price. It is the number one factor in a decision for an internet selection process for a customer. The first thing they look at, price. I know we don't want to hear that, but we have to acknowledge the reality here, and we'll figure out ways how to make that an okay realization as we talk through this a little bit more. Talk about experience. Now, I'm a millennial, so that doesn't mean a lot to me. So let me put something to that. So when I say experience, I mean service availability and my customer experience. Again, everything Brian was talking about that green bar, when I'm utilizing my applications, how does it feel to me as a user? I show the Wi-Fi because that is one of the major causes of experience problems. I show customer support for two reasons. One, how does it feel when I pick up the phone or send a message to my customer support? Am I getting ChatGPT telling me something I don't know or care about? Am I getting a real person? Did it take me an hour to get a real person? Better yet, did I not have to call because I didn't have a problem? That's the best kind of customer support. And then, okay, in experience, there is a little bit of speed. Kind of, think about peak time. If I experience congestion, that's related to speed, right? It's not directly speed, but it's still in there. It's part of my experience as a broadband subscriber. And then everything else. You'll note I have my little green leaf here because that is everything else, especially in this part of the world. There's a lot that goes into it. There's brand reputation, but really, we're mostly talking about eco-friendly. Now, as I look at the slide, I see that top left. I've simplified it here because I've said that if I'm going to select a broadband service, these are my criteria. That's not a real world scenario. I need to think about something far more practical. Do I have a choice? I live in Austin, Texas. I have one provider and cellular. Those are my two choices. It doesn't matter what the price is. It doesn't matter what the experience is. I have two choices and I'm deciding between one of those. We can't ignore that, and we have to talk about how we use that information to guide our decision processes, guide our investments, and actually build a service that is available to customers. So I'm using a US example here, and you'll understand why in a few minutes. This is the problem that I, as a broadband provider, face in the US. This is AT&T. They're the second largest carrier in the US coverage map. They're everywhere. They're everywhere with,
Is that mobile coverage or is it?
it's, well, you tell me. Is it mobile or is it a hotspot? It's everywhere. They're selling FWA, they're advancing their networks. They have some service at every part of the country. And that's just a reality. I'll also tell you that, again, I live in Austin, Texas. AT&T cell service is 50% of the price of a fixed line service. 50%. It's available and it's cheap. Going back to my NPS score, those are my first two criteria. How do I compete? What do I do? How do I make sure that I am actually getting customers, sustaining my business, and still attracting new wins? Well, I have to address the everywhere part. I have to be able to serve a customer, no matter where they are, with a fixed line solution. Brian teed this up for me a little bit because he talked about how AI models can think about how network congestion works. I don't necessarily talk about AI, I'll talk about machine learning because that's really what it is, it's an algorithm. But what if I had an algorithm that considers build cost and considers pole attachments and local legislation, because I get charged for crossing certain streets, build costs, and it tells me how to most effectively take a fiber from point A to point B. My costs go way down. Again, it's not necessarily AI, but when you give a solution like that tools to leverage outdoor enclosures that sit up on a strand, or little nodes that sit on a wall, they can leverage outdoor cabinets, or they can leverage head ends. Suddenly these AI models, or machine learning models, are able to take a physical Google Maps image and tell you how to build a network cheaper. It's as simple as that. They are reducing construction costs, mitigating construction costs, and mitigating sort of soft costs associated with pole attachments and permitting. It's a really, really powerful, important aspect, and we need it because we have to start bringing our service as a fixed line provider everywhere. If we're going to compete, that's availability is number one, so get everywhere. I'm also going to address this little cloud I have on the top left. I think, again, I owe Brian a beer for 10. We talked about a virtualized core site, and we talked about needing to be able to do analytics in a centralized location. What if we had that? What if that's not theoretical? What if we have a place to run all of our analytics? We have a place that is a single pane of glass, regardless of what the physical infrastructure looks like. It normalizes everything that we have to build, and it gives us one computer screen to manage, monitor, and deal with it all. Virtualized core set is a beautiful thing. This is that same concept extended. And I've actually added a layer here because I've been talking about fiber. We're the SET. There's a C in that name still. On the left, I show my virtualized core site. I'll talk a little bit more about what that actually means, but for now, let's call it the brains. I show a broadband connection traversing to a random building, somewhere in your network. I don't care where. Machine learning will tell me where it goes. And I show it traversing to a node. Again, these are representative. I'm actually not dictating it. You could put anything in there. It's ultimately just representative of whatever's optimal for the specific scenario we're talking about. And on the right, I show a DOCSIS 3.1 customer getting 8 gig of broadband with a standard cable modem. This is today. This isn't DOCSIS 4.0. This isn't something in the future. This is a DOCSIS 3.1 with your existing coax network, your existing spacing, 1 gig or 1.2 gig plant. There's a trick here. Nobody else in the market is talking about 8 gig 3.1 today. But that virtualized core set on the left has made it possible. Go back to those 26 million subscribers I referenced in the beginning. They're all connected to a virtualized core site. That core site turned up 8 gig DOCSIS 3.1 immediately. It was a software upgrade, just like the iOS upgrades that you deal with on your phone. That was available 3 years ago. We just had to upgrade the actual modems in the home to make it available. We care about fiber, and we want to make sure that we're still building fiber everywhere. So go back to that machine learning model, and go back to the fact that when you build a network, you're going to have super users. You're going to have your gamer who consumes a ton of bandwidth, who downloads, who plays all sorts of video games. Put them on a fiber. What if that fiber comes from the same node that's already serving your DOCSIS network? Edge out in minutes. These are literally modules that plug right into the exact same node. It does both simultaneously, and you had to have that top network, or you have that top network today anyway. So suddenly, I've given you the ability to serve your high-tier customers with fiber to the home, with a faster, better service, and I've relieved your DOCSIS network because I've taken them off and I've put them on their own separate fiber. It's a really cool tool. Again, don't worry about what I say. The machine learning model will tell you when to use this. And then you go back to that machine learning model and you say, every one of these sites, use that as my aggregation point for future builds. Use that existing site to avoid building new cabinets, building new buildings. Use the node as a switch on a pole. That's what it is. If that's a cabinet, avoid, mitigate all of your construction costs, keep it as controlled as possible, and extend your network edge out as far as you can, as cost effectively as you can. This starts to solve availability problems and starts to give us a path to competing with cellular service with FWA, which does have that ubiquitous coverage. But the problem with all this, it's expensive, right? Like, if we could all build fiber everywhere, we would. It's expensive. We have limited budgets. We have to manage that. And we can't just go to the customer and say, your service is $1,000, Mr. Customer. They'll walk away. How do we do it cost effectively? Step one, machine learning models will help us optimize those networks so that we are not overspending on the network. Again, I promised you that that virtualized core would come back. This is developed by my company first in 2016, in production ever since, 26 million users. It's a server with an app on it. I'm showing the fiber to the home app because I like fiber. But ultimately, it's a cloud compute. You want wireless, it's on your top left. You want fiber to the home, you want DOCSIS. They're all coexisting on a single cloud. If you look at the definition here, it's infrastructure built to handle all this processing, and ultimately it rapidly scales either way. Come back to our power question in a minute here. It adds apps and functionality like machine learning, like AI if we ever get there. That's why again, we're not quite at machine learning or AI yet, but we certainly have machine learning. And I'm gonna sort of prove that second here. That fourth bullet, deliver 5 nines availability. What if I told you that wasn't a theory? That was my measured delivery performance against 26 million customers. I've taken the concept of optimizing my network and using a machine learning model to point me to problems. I'm doing it. And when I fix the active problems, the responsive stuff, then it's converting it into, hey, proactively go fix this. Proactively go replace this. Proactively go improve your network. It's not even impacting customers today, but it will in the future. It's just doing statistical analysis, let's be real. It's not AI, it's machine learning, it's mathematical models, but it's a proven operational model. This is where it's sort of, again, Ryan talked about transition from functional to operational. We're kind of in the middle there. You can deliver this and it starts to become strategic when you're getting that kind of performance. Just for context, 5 nines availability is actually a little low. 5 nines availability means that the average customer of those 26 million has 5 minutes and 26 seconds a year of downtime. My actual delivery, 5 nines, 5 8. It means I'm under a minute of average downtime per customer. That's a big deal. It's a function of that proactive maintenance and that ability to actually take data and analyze it. I think Brian also mentioned terabit data. That's absolutely key. This is a massive amount of data. Every device, every home, and this is not the application layer, this is the physical layer, generates 1.7 million data points a day. It's incredible. The way that we have to sort of condense that, those 1.7 million data points per customer might translate to 10 total recommendations for an operator, even if they have 1 million customers. Those recommendations are plain English. I can read it, you can read it, our accountant can read it. It says, in a sentence, go fix node 127 port 2. It's not, hey, RF levels. It is plain English that anybody can see. Unfortunately, or maybe fortunately, CTOs are being held accountable because this data is available today, and the CEO can go check, and he gets the same 10 sentences that the CTO gets. So if there's an outage, there's a sentence that says what happened. It's not necessarily ChatGPT, it's not necessarily customer facing, but this kind of analytics on the physical level exists. It's slightly different though, because it's not application, which is an important distinction here. This is very much the power levels, the RF levels, the actual network itself, and not YouTube, Amazon, etc. This changes the underlying economics, like a lot. But don't believe me. Oh, damn, that's the next slide. I have to do all of this, and I have to be cost effective, and I'll come back to that in a minute. It's on the same slide as my power data point. So I talk about cost effective here. I wanted to also show a unique innovation which creates a lot of overhead, which we don't talk about a lot. One of the major areas which customers are in, their physical location, they're in MDUs. MDUs, apartments, hotels, etc. When you look at what it costs to build one of those sites, you often find that your overhead is actually rewiring in the building. Many of these sites were built sort of 90 and before, and they have coax in the wall. It's extremely expensive to go rip out that coax and replace it with fiber. So actually one of the messages that we purvey is leave it. Build fiber everywhere else. Leave that virtualized core, leave that network insight in place, leave whatever that network looks like, and build fiber to the home. But when you get to an MDU, convert locally back to coax. You put a little box in the basement about that big, goes on the wall, takes your PON in, takes your fiber to the home in, outputs your coax. It actually improves the service of that coax because it's locally deployed. It improves the power levels, it improves the customer experience, and it's all done without rewiring the building. Suddenly you've given that MDU sort of fiber to the home experience without the cost of rewiring. Major way to change the delivery cost for those big sites. And avoid vendor lock. I didn't talk about this yet, so one of the really unique, powerful aspects of a virtualized core is it gives us the ability to iterate on software very, very quickly without you're able to develop, deploy instantaneously and very agilely. One of the ways that gets implemented is a strategy called Open ONU. This is where you as an operator get to pick whatever your preferred vendor for in-home devices. Maybe that means, I actually removed the silicon vendors' names because I don't like saying it, but whatever the cheapest is, maybe it's that. Maybe you want the best Wi-Fi. You get the choice to optimize your in-home experience and optimize that customer perception of your business, however you want to frame yourself. Not being locked in gives you a lot of flexibility to choose and manage your business in a way that maybe you haven't been able to previously. So I got back to that experience piece, and I said that I would show you some data on what this actually means. So the reason I started with the AT&T coverage map earlier is because AT&T gave me a wonderful data set, and a company called OpenSignal is responsible for this analysis. So full credit to them, check them out. It's a really, really cool organization. On February 22nd, AT&T had nationwide outages. Still haven't explained exactly what happened, but it was across cellular and fiber. Red is your outage. Percentages of devices showing no service. Well, what did that mean for AT&T customers? They changed service. On the right, this is a churn. Red is churn. Look at that correlation. We want to differentiate ourselves. We want to go win customers back. We deliver a better experience. Fiber and coax, fixed line solutions that are reliable will win. A fiber customer is a customer forever. A cellular customer is a customer until the next storm. The data shows it, and when we go back to thinking about how we justify the investment of building fiber everywhere, we get to model out fiber over a lifetime. Amortize that investment over however long you want to, because if you have that level of reliability, if you have a cost-effective service, you will sign them up and you will retain that customer in a way that no other technology and no other vendor will. So going back to my Open ONU comment, Wi-Fi iterates very, very frequently. And when you think about customer experience, it is one of the key drivers. Having the ability to constantly select and pull in that best Wi-Fi solution, thanks to a virtualized core, is critical. Wi-Fi 7 just came out. it works today on all the virtual cores because somebody asked for it and we did a test, open ONU, it works, great. They get to deploy it tomorrow. Think about all of the competitors in this market who have vendor-locked ecosystems who are waiting for their vendor to come out with that next great CPU device, that next great Wi-Fi. They might be stuck on Wi-Fi 6 for another year. Now you can actually go and capture those customers for yourself because you have a better experience. Some other folks prefer mesh Wi-Fi, same logic applies. If you have a preference for mesh Wi-Fi, having this flexibility gives you the leverage to go utilize whatever the best in-home experience is and continually stay at the edge, the front edge of that customer experience. And last but not least, when we think about what drives NPS, I said it earlier, everything else. So economics and ecological fairness and sort of friendliness is a really important aspect for all businesses, but it often gets put in last place. Thankfully, and this is not my data, Vodafone published a solution or published an article with Intel. It is 100% my technology, talking about what happens when they deploy a virtualized core across their network. 28% reduction in power. They have all that data I just talked about. They have machine learning, not AI, machine learning. Again, there's a nuance there, but they're capturing the benefit and they're getting that 5 nines reliability, availability with machine learning. As it continues to iterate, yeah, they might add a 6th nine, a 7th nine, an 8th nine, and they might lose a couple percent, but this is still a massive improvement. And I promised you that I would talk about what it does for total spending. Again, their published data. Capital expenditure reduced by 46%. Come on, that's not something we can look at as businesses and say, yeah, we can cut our costs by half. Let's not worry about that. That's a priority. If we're thinking about price, and we're thinking that price is 1 or 2 in terms of customers' top priority, changing our cost structure, reducing it to make ourselves competitive, we've got to prioritize it the same way that customers are. So again, this is not my data, this is my technology, so I'm very happy to power this and support this. But we're fundamentally changing the economics of broadband through a virtualized core, through a little bit of machine learning, and through a flexible portfolio that gives you access to all these different devices. So the punchline, why do you care? Again, virtualized core reduces TCO. You can look at the Vodafone data. You can also look at, in the last 2 weeks, 3 weeks, I announced wins at Claro and Millicom. I'm a US-based company. I beat ZT and Huawei. How many times has that happened? Sort of unheard of. The way that we beat them is we weren't competing on fair grounds. We have a virtualized core which absolutely changes the pieces that are required and gives us a way to solve the problem more efficiently, and it shows up directly in the cost. Shorten time to market. Utilize hybrid nodes. Utilize nodes that are capable of serving DOCSIS, of serving PON, and serving as edge out locations for future market growth. You have these massive valuable networks today. We can remonetize those assets, we can get more out of them, and we can expand them effectively. All the while, you get to capture high value customers who want PON today by targeting them. Again, use that targeted PON for super users. Take those gamers and put them on PON tomorrow, even if they're on a DOCSIS service group today. And innovation. Again, I'm not doing AI yet. I'm doing machine learning. I'm already getting 5 nines. How far can we take that? I'm already supporting Wi-Fi 7. What's next? And Central and Sonar, I don't have a pretty picture for this, but this is actually, these are our brands for like automated deployment, right? Because ultimately when you do all of this stuff, You don't want to be sitting there at a keyboard typing endlessly. You want to be scanning a QR code when you walk out to a field, and you want the entire thing automatically configuring itself, and it's actually not even one touch, it's zero touch, because it's a QR scan. Thanks to the virtualized core, that's all possible and real today. So, affordable, reliable, available everywhere. We can change the way broadband looks. We can compete against wireless. We can actually just improve the experience for our current customers, and we can drive our customers' perception of us as service providers, of our solutions, and of the way we interact with them by utilizing some of this technology. It's available. We should be capturing it. Thank you. Questions?
Dan, you talked about hybrid nodes. So you talked about hybrid nodes.
Yes.
North America, your nodes are typically a lot bigger than they are in Europe. How do you deal with reduced form factor?
They're still hybrid nodes. The small form factor nodes are also hybrid.
Have you been a switch to those?
So in fact, yes. In fact, same, all sorts of options. So, everything specific to my portfolio, everything Harmonic does is sort of modular. So it's designed so that it fits into multiple form factors. Europe has, I think, 4 or 5 different form factors that are much smaller because they're designed to be low visibility, low intrusion. They do support DOCSIS and NPON simultaneously. Also in Europe, there's a high volume of shelf-based form factors, and those also support DOCSIS and PON simultaneously. So I think every node Harmonic has ever deployed since 2016 supports hybrid. So yeah, 150,000 plus. Not a bad metric.
Hurry up.
Make it hard, Adam. Come on now.
Awesome job, Dan. Loved it. Question about all your nines.
Yeah.
Obviously, cable network, long cascades, a lot of stuff. You're talking your virtual core, we can imagine it in the head end, cable modems in the house. There's a lot of stuff in between. So tell us where and how, scope in that nines, because if there's a power outage, someone crashes into a cabinet, there's a lot of stuff in there that's outside your control, right? So tell us how you're measuring that a bit more and how, flesh that out a bit.
Yeah, I'm measuring it all because I have to. Because if weakness is the power supply, because I need a generator, then I'm going to actually flag that as an outage because I want attention going to the fact that the node went out and maybe it needs a better UPS locally or a better generator locally. So I want that data because it's guiding how I improve my network going forward. Cascades, the same thing. We know that there are N plus 18 cascades out there. Okay, well, you put it up there, you see your data, and it's going to come up with 10 recommendations for you automatically, and maybe 9 of the recommendations are going to be remove amplifier 1, 2, 3, 4, 5, 6, 7, 8, 9. That's okay. We want to know that, and we want it to be done statistically so we know the impact of not doing it, right? It's prioritizing based upon the number of customers who could potentially be impacted. So having it's okay, the system will tell you what to fix and how to prioritize your resolutions.
So you're effectively saying you're measuring from your virtual core all the way to the cable modem edge, and it's still 5 nines.
Yeah.
Okay.
It's it sort of doesn't matter what the problem is because to Brian's point, a lot of it all gets sort of fudged together. Right? We're not doing application level experience. I think that's an important nuance here because the application level experience is different than the network level experience. But from a network congestion standpoint and a network refinement standpoint and investment standpoint, we have to consider anything, even if it's outside of my direct control, and prioritize that based on the breadth of the impact. So yeah, it's almost got to have all of that by the nature of it. It's a good question. Power investment is one of the largest areas of investment that we see going into this. It's a risk for a lot of operators who have old power or lack some redundancy in that ecosystem.
Any more questions?
Hi, Dan. Yeah, very interesting and impressive on the Vodafone, 48%. I'm interested, where is that? What location, what network, and over what period of time did it take Vodafone to achieve their results from saying, okay, we've got a problem today, and then you come up with this fantastic saving of 48%?
So I would actually, it's Germany. I think Mike would actually confirm that. It did take them a while to sort of get to a state where they started the clock. This was published about 8 months ago, and I think they did a full 12-month study. It was particularly done when there was massive fluctuation in the power prices in Germany. So it was a very high priority for them. But again, I defer to the actual article for the details of where and when. I forget it. It's a little dated for my memory.
More questions? Are you that thirsty now? There's no more questions.
Are we really there? I'd like to thank all of our speakers. Dan, really well done. Thank you very much.